So thank you for the introduction, and also thank you for giving us the opportunity to present our project here today. So I will present AURORA, which stands for Accelerate the Deployment of Integrated CCUS Chains based on solvent capture technology. And you already mentioned the title is very long, so I don't want to repeat it. But I would like to highlight my contributors to this presentation. So Hanne Kvamsdal from Sintef, she is the project coordinator. Stefan Jouen from Total Energies, he's leading the specific work package on the CCUS chains. And of course also Sabina, I'm not sure if she's here now, but she's been here earlier today, yeah. She's also part of the project. Yes, so let me see if I can figure it this one. Now, enter. No. Sorry, it skipped ahead a bit. So just briefly about the AURORA project. So it's a Horizon Europe Innovation Action Project under the call Decarbonizing Industry with CCUS. So the project period is from January 23, so we almost just started. Hence, there is not that much results just yet. But what we have so far I will present, and the project will end in June of 26. The overall budget is almost 16.3 million euro, with about 12.2 million from the European Commission. Sorry, is it not? I'm trying to, okay, standing a bit away from the microphone, sorry. We have 12 partners in total from 6 European countries. And then specifically for this talk, of course, Greece would be a specific area to look into. So, still figuring out. It keeps skipping too far. So our project partners, we have, of course, partners from research and academia, and we have industry. So these would represent, in this case, emitters of CO2. We also have a technology provider, so Aker Carbon Capture. In addition, there are 2 SMEs contributing to different aspects of the project. I'll try and do this correct now. Yeah, so the AURORA project, its main focus is to optimize CSR1 as a solvent, and then further the CO2 capture process. So CSR1 is an amine-based solvent consisting of piperazine and AMP. It has been developed in several EU projects, I think since 2010-11-ish, and has been adopted as the new benchmark technology by IEA GHG. So this project is to further evaluate CSR1 as a solvent, and it is important because all data will be open, so it's an open source solvent. We have a lot of ambitions. I'm not going to go into detail, but specifically for the focus on this in this conference, one of the ambitions is to ensure safe, full CCUS chains. And this will feed into the whole innovation. So in addition to doing the pilot scale demonstrations on capture, we will then adapt that further to assessment of full CCUS chains for cluster development in 2 countries in Europe, so namely Belgium and Greece. And hopefully by the end of the project, we will have completed and validated the system, so specifically the capture part of the system, towards first-of-a-kind capture plants. And also ensuring that the results are replicability, and transferability. Nope. I think you're all quite familiar with the different elements of a CCUS chain. So we have the capture block, the first block here. Then we have conditioning, and finally the transport block. And all of these are integrated in some way and feeding information between each other, and will then influence the design of the different blocks. In addition, we will do TA, so techno-economic analysis, on these different blocks, and then that will feed into the life cycle assessment. In addition to this, of course, we have to adhere to regulation and policies, so that's a very important aspect when we're building these systems. And finally, all of these will then produce KPIs, so key performance indicators for the CCUS chains that we are developing. So what we're doing so far is source and sink mapping. There was a presentation earlier today. We adapt much of the same methodology for emitter mapping, focusing then specifically on Belgium and Greece. In addition, we do sinks mapping, so storage sites mapping. So for the Belgium case, we are primarily looking at the North Sea region, and we're most likely going to go into existing or planned infrastructure. So either through Northern Lights or the Portos, or similar projects in that region. For the Mediterranean, I will get back to that. And then we also have a small part on CO2 utilization. And at the moment, it seems like methanol production is the most likely approach. So as I mentioned, we focus on Belgium and Greece. So we're looking into local, regional, and national emitters. So we need to identify industrial clusters, while also keeping in mind mid and long-term vision. So another aspect that has been highlighted, especially by the industry partners, is that they very much like to look at clusters. So how can they collaborate with the plants around, and to what extent do we go? So we need to assess single versus cluster approach for different elements of the CCUS chain. And the potential of the clusters depend on the definition. So we have inside an industrial park, for example, that's defined as local. Then we can have collaboration from capture to storage. We're also looking at industrial regions, if we can identify these clusters based on specific assumptions. We can have collaboration on part of the transport chain, and hopefully also towards storage. And again, national, very similar to region, collaboration on the transport and storage. There is an illustration on the slide as well. It highlights the idea about clustering. So we're looking at the primary source for CO2 capture. And after that CO2 is captured, it continues to conditioning, and then possibly to transient storage or directly to transport. And depending on how we build up the chain, you will likely have a hub, again with transient storage and reconditioning of the CO2 if the next transport step is different from the first. Additional transport, and then finally CO2 storage. And along this chain, we foresee that we will have different emitters that can join at different locations, preferably at hubs, which has already been also discussed briefly today. Let me see. So for storage in the Mediterranean, we have some areas of interest. This was also presented to some degree yesterday. So we have the Adriatic Sea geological province, which is one of the most important regions for natural gas and oil production in the area. We have onshore southern Balkan area, so potential areas here is northern Greece, Croatia, and Romania. And then the Ionian Sea and eastern Greece, so in deep silane aquifers in the Greek Mesohellenic basin, and existing depleted hydrocarbon fields in the tertiary sedimentary basin of Pinus. And in addition, with reference to the previous speaker from Carbfix, there is an option also for the Volos area in Greece, where there is alkaline basaltic lava, so possible for direct carbonation, and this has come up as an interesting topic that we probably would like to explore further. So for full chain development, the design will very much depend on the location of the sources. Do we have more than one? Do we look at single or cluster approach? The CO2 stream purities, temperature, pressure from the capture plants, the type and location of the CO2 sink, where is it? So stored with the reservoir characteristics, impurity limitation, temperature, pressure, is it onshore, offshore? And for utilization, it's the CO2 specifications that will be the major design criteria. We will likely have regulatory limitations. So for example, is there any limitations for onshore pipeline transport pressure? And we have encountered that before, and that's interesting because then you need to rethink your process. And type of transport, ship and pipeline, trucks, barge and rail could also be necessary. Again, temperature, pressure and CO2 purity limitations. And then we need to look at the number of transport stages, need for hubs and reconditioning of the CO2. So this was in the application. So these are very much initial sort of chain development. So for Belgium and Greece, so Belgium of course is the top star, while Greece is towards the bottom of the picture. So for Belgium, we have two emitters, the Umicore plant and Total Energies refinery. The idea is to transport the CO2 either by pipeline or ship or a combination out to either a suitable location outside of the Netherlands or to the Northern Lights project. And for Greece, these are of course just preliminary chains. So again, we have two sources, the motor oil refinery and the Herakles cement plant. And again, pipeline, ship, and a combination possibly. It's also here probably exploring somewhat further also this offshore possible injection from ship. So direct injection from ship is becoming an interesting topic as well. Yeah, and finally, I want to touch back on what we initially said in the ambitions, to develop replicable and transferable full chain methodology, amongst other things. So for the methodology for the full chain CCUS, currently is that we need to map regulation and policies, both regional, national, and European. They will be the overreaching or defining framework for the further development of the chains. We will do flow sheet design, so process design and optimization, and also, of course, integration. In addition to the flow sheet design of each of the elements in the chain, we also have quite a high focus on sort of monitoring the flow of CO2. And this is very important for keeping track of the CO2 through the whole system, and also for emitters to ensure that the CO2 is taken care of through the whole chain. And then we, of course, will do cost estimation and life cycle assessment, assess the social and political readiness, and all of this will feed into different KPIs, so key performance indicators that will be used to evaluate the different chains that we develop. And as I said, the end goal is to have a replicable and transferable full chain methodology for these CCUS chains. So, and hopefully we can come back when we have come a bit further in the project. So yeah, thank you for listening.
Thank you, Annette.